Let's go to Liquid 1838, frequency of the most frequent element. So this question here give us integer nums, and you can do at least k operations. The operation is that increment a number by one. That is an operation, and ask you the maximum possible frequency after performing at most k operations. So let's look at the example 1 to 4, and there is a key we can operate 5 times. So if we increase 1 and do 3 operations to 4 and do 2 operations to 4, all of the elements can get false. So the highest frequency will be 3. And the second question, second example, that is if we can perform 5 operations, the highest will be 2, right? So basically, what we're thinking about is that we can think about is that we for these numbers, right? If we have a sort the numbers, you see, because the example 3, right, that it's not sort, and we have to compare the things that intuitively we're thinking about is that we should increase that number to its next greater one, right? So we saw this number. For example, we have this kind of arrays. So we can try to see for this kind of array, we're trying to sum. We can have a iterator. For example, we have I as a right pointer and j as a j pointer. The things that if we can, for example, we can like put a sliding window, right? In this window, the sum of all of the element in the window I and j plus k. If it is greater than the biggest number, for example, numbers I multiplied by the length, I minus j plus 1. That means the sum. That means for this window, all of the elements we are able to increment to at most k times to have the all of its element to be non-psi. So in this case, we can expand the windows. And in this case, we can expand our I window, I pointer, right? So we can use a while loop, right? And while this kind of condition satisfies, that means we can keep increasing the window. And so if it's not, then we move j, right? So in that case, we have possible have a global the frequency is I minus j plus 1, right? So in this case, we can have a local max frequency with the left index j, right? And until we move iterate the whole array, and with a maximal frequency, and compare that update the global one. So let's begin to write code for this. As we know, we need to we need to sort the array, right? This is what we need to do. Otherwise, the numbers in the in array is not in order. So let's sort nums. And let's have int. This will be the right pointer. J will be the left pointer. And let's have its length. And the things that we'll see this I and j, right, in this kind of range, 10 to the power in this kind of range. So so it's if the worst case that if we have the maximum to be 10 to the power 5, right? And for this current, it can be out of the integer range. So let's have the user long as window sum. So let's do for I is the right pointer, I smaller than n, I plus plus, right? So for every move, the right pointer will have some plus equals to nums I, right? So what we do is that while we see this is sum sum plus nums plus k, right? If this is already smaller than the biggest one, right? Nums I multiplied by the window size. Window size is I minus j plus 1, right? Have 1L multiple. So if that means we need to move the left pointer, right? So we'll have sum minus equal to nums j, and j move the left pointer, right? So after we move this, we just have a global result, into result, right? Yeah. So we'll just have result equals math.next result I minus j plus 1, right? In the end, we just return result, right? So we know for this kind of while loop, right? So the things that if this conditions satisfied, we can we use a for loop, right, to keeping expanding those kind of right index, right? And if this kind of condition happens, that means we no longer can add a k to have the it to the maximum in the window size multiply the length, right? So in this case, whether we should shrink use a while loop to shrink the left pointer is actually we have some optimal solution. Is that we just use a if, right? If and in this case, what we do is that we just move left pointer by 1 index, right? And we don't need to keep to update the global max anymore, right? So So in this case, at the end, I is out of the range, right? And I will be in, right? So what we do is that we instead update every time for the local max. What we need is that we don't need to have this result. We just have you return I minus j, right? Because that means if our window is already expand, right? Expand to those kind of conditions that we can have a sum multiplied by the maximum one greater than sum plus k greater equal to the maximum multiplied by the length, right? So we keep that window to move until we finish. So in this case, it's better than the while loop, right? So if we have the window, we will not shrink the left pointers. Doing like this, the time complexity, we sort these numbers, right? So it will be n log n space is constant.